Welcome, pre-algebra class, to another episode of Mr. Chow Time. This one is a little bit late. I apologize for that. This one is lesson 5 on factoring linear expressions. So, factoring. What is factoring? Well, a factor is a number or the set of numbers that you multiply to get to a number. So, for example, if you have a number like 12, if you want to find the factors of it, you're going to find all of the whole numbers that you can multiply to get to that number. So, for example, 1 and 12. You can multiply 1 by 12 or 12 by 1 to get to 12, right? 2 and 6. 3 and 4. So these are the factors of 12. The greatest common factor is the biggest factor of two numbers. So, for example, if we were doing 12 and 15, 15's factors are 1 and 15, 3 and 5, and that's it, right? So what is the biggest number here? 3, right? Because this set has 15, but the set does not. The set has 5, this one does not. 3 is the largest one. That's the greatest common factor. So, how are we going to use this? Well, let's find the greatest common factor for each pair of monomials. There's a couple of different ways we can do this, right? We can look at these two numbers and do what we just did, which is find all the factors. So for 4 and for 12, that would look like this: 1, 2, 4, right? And then for 12, it would be this: 1, 2, 3, 4, 6, and 12. And then the biggest one is 4. The other way of doing this is using a factor tree. So a factor tree looks like this. You write 4, and then you write the factors of 4 that are not 4 itself or 1. So, for example, 2. And then when you get to a prime number, you just circle it. This is called prime factorization. A prime number is a number where the only factors are 1 and itself. 1 and itself. So, for example, the number 5 is prime. So the only factors of 5 are 1 and 5. For 12, again, we're not going to use 1 or 12. We're just going to use other factors. So, for example, you can do 3 and 4. And 3 is a prime number. And then 4 is not, so we just keep going. 2 and 2. And there we go. This is the prime factorization. So the prime factorization of 4 is 2 and 2. And the prime factorization of 12 is 2, 2, and 3. Then you just kind of link up the common factors. So, for example, 2 and 2, 2 and 2. Then whatever numbers you've multiplied or whatever numbers you've circled, you just multiply these two together. So 2 and 2 is 4. 2 and 2 is 4. So 4 is the greatest common factor. Now this is useful a little bit later, but either one of these is fine. So the greatest common factor here for the coefficient, the number in the front, is 4. Now because they both have x, that is part of this number, right? So x would also go into this, and then x would also be part of the factor, which means that 4x is the greatest common factor for these two numbers. So let's do that again. 18ab, 20ab. Well, we can see that A is common for both of them, right? So we can write that immediately. But B is not, so we won't. For 18, I'll do one this way, and then I'll do one this way. So for 18, I'll do it this kind of prime listing, or the factor listing method. No, I should do them both the same way, huh? Let's do it this way. 1 and 18, 2 and 9, 3 and 6, and that's it. 4 and 5 are not factors, and then you get the 6, and then you know you're done. Okay, and then 20, 1 and 20, 2 and 10, 3, 4 and 5, and again, we're done. Right, so the biggest common factor here is 2. Right, 3 is not common, 5, 6, 9, 10, 18, 20, those are all not common. So 2a, that's the factor. Okay, your turn. So 12 and 28, the factors of 12 are, well, I'll do a factor tree here. 2 and 6, 2 and 3. So those are the factors. Here we have C, and then 2 and 14, and 2 and 7, right? So they both have 2 2s. So the greatest common factor is 2 times 2, which is 4. Here, they both have M, and they both have N. So N is for sure going to be a factor, right? But I'm not going to write it yet. And then 42, so that can be 2 and 21. And then 3 and 7, and we're done. And here we have 2 and 7, and we're done. So 2 and 7, 2 and 7. So that means 14 is a greatest common factor, and then M and N, because they both have M and they both have N. Okay? All right. So the factored form is an algebraic expression that is factored using the distributive property backwards. So what does that mean? So if you have an expression like this one, then we can find the greatest common factor of the two terms. And in this case, that's going to be 3. And we're going to be able to divide both the terms by 3, because that's the greatest common factor, right? Any number, we'll just go back to 12. Its factors are all numbers that you can divide 12 by, right? And since 3 is the greatest common factor of both of these, we can divide both of these by 3. So if you divide 3x by 3, you get x. If you divide 9 by 3, you get 3. The operation in the middle is a plus, so we put a plus in the middle. Now, factoring, to get the factored form, is basically the opposite of distribution. Distribution and factored form, I'll just write it, are opposites. So if we come back to this page, 3 times x plus 3, if we were to distribute this 3, we would get 3x plus 9 again and return to the original expression. Okay, so can we, is there anything that 12 and 7 can both be divided by? No, not other than 1, right? So this one cannot be factored. Okay, your turn. Welcome back. I'm just going to breeze through these. This is going to be 4 times x plus 7. This is going to be 3 times 1 plus 11x. And this one is going to be not able to factor, or cannot factor. Okay. So So here is a real life situation. Let's say that we have this garden, and the garden has a area, or has two pieces. This garden has two pieces sitting next to each other. One has an area of 15x and one has an area of 18. So if we add these two areas together, we get 15x plus 18, right? And that gives us the area of this entire thing, these two pieces together. So we want to find the possible dimensions. Dimensions are this and this, which is basically length and width, right? And the area of this whole thing is then length times width. That's the area of a rectangle, right? And we know that the whole area is equal to 15x plus 18. So we can substitute this, right? We can put this 15x plus 18 over here. So length times width equals 15x plus 18. So we want to find what times what equals this. And we want just a possible dimension because there's a lot of possible answers. And what we can do is we can factor this out. So if we factor this, the greatest common factor of these two numbers is 3. 3 times 5x plus 6. Now we have two different terms multiplying each other, right? We have this one and this one. So that is our length and width. These are possible dimensions, 3 and 5x plus 6. And we don't know which one is which, but maybe this one is 3 and maybe this one is 5x plus 6. Okay, your turn. The Chen family has saved $480 as a down payment for a new go-go row. If X is the monthly payment for 1 year, then this expression, 12X plus 480, represents the total cost of the television. Factor the expression. So 12X plus 480, this is the total cost, right? And they want us to factor this. So, 12 is the greatest common factor of these. So this is going to be 12, or I'm sorry, X plus, and then 480 divided by 12. And what is that? 480 divided by 12. 12 goes into 48 4 times. 40. 12 times X plus 40. Okay, let's say that Jerry wants to put down $1,000 toward a new computer and will pay it off in 6 months. If Y is the monthly payment, what expression represents the total price? Welcome back. All right, so here we're going to have to write an expression, right? Well, for 6 months, he's going to pay Y dollars, and he already paid 1,000. So let's factor this just for practice. So the factors of 6 and 1,000, I believe that's going to be 2. So 2 times 3y plus 500. All right. Great. Here is your must-do. Enjoy.